Hello, good morning, everyone, and I welcome you to today's class. And I hope you are keeping safe and sound and healthy. We thank God once more for the opportunity for us to learn. Today, I will be sharing my slide and we will be discussing application of statistical concepts in economic analysis. Application of statistical concepts in economic analysis, and that is our lecture 13 as we have it on our course outline. And the outline of my presentation or lecture today would follow this pattern. We'll have an introduction to the topic, and then we shall be looking at the various ways of applying the statistical concepts to economic analysis. So, as a way of introduction, we need to understand first that statistics is relevant to every field, both in science and humanities. Statistics is very relevant to every field in science, in medicine, in engineering, in um, animal science, in human science. They are all relevant. And as well as humanities, when you look at the social sciences, look at art, statistics is relevant, is vital. So we must understand that as a way of introduction. An understanding of its complexity can be used, all right, to understand human behaviors. When we understand the complexity of statistics, we understand the dynamics, the theories, the issues related with that particular concept, all right, it will help us to understand human behaviors. And this will then further the development of the society. So, when we have an understanding of the complexities of statistics, the theories behind it, the ways behind it, the dynamics behind it, this will help us to the development of our society. And we should also understand that the application of statistics to economics is a bit distinct from other social science fields. Okay, we have other social science fields, psychology, sociology, political science, geography. All right, all of those other fields discusses human behavior with a society. All right, with a different perspective. For economics, all right, we consider statistics very important and germane, okay? And it's a bit distinct from others because in economics, we try to understand how our limited resources, okay, can be efficiently utilized in order for us to maximize our desire. So if we look at how our limited resources can be matched against our human desire, our needs, okay? Statistics becomes pivotal in that particular analysis. Statistics become very relevant when we seek to understand how these resources can be matched against our needs. So, from identification of the resources and identification of our needs to matching of them, statistics is very relevant. And so statistics will help us to measure those resources and then we can now match them against our needs. So from the beginning of economics to the end of economics, all right, statistics plays a critical role. And that is why I say that statistics is the foundation of economic analysis. Statistics is the word foundation, all right, the basis, the beginning of economic analysis. Remember that our economics, okay, establishes relationship, but there is a need to measure or analyze such relationship, and that is where statistics plays a critical or a vital role. So we will be looking at those various ways that we can apply the concepts of statistics, all right, to economic analysis. The first we'll be considering is validation or testing of theory. That's the first. Okay. And statistics is a set of analytical tools that can be used to test our economic theories. Okay. As a beginner in economics studies, I wouldn't go too deep in considering other economic theories, all right? There are so many economic theories, and you will be learning them from this your year one until your final year and even beyond. So I will just use the simple theory that you have been exposed to understand how we can analyze and test economic theory using what? Statistics. The first one we consider is the theory of demand. When we say that we can use statistics to validate, or we say we can use the statistics to test economic theory, what do we mean by that? Economic theory, okay, has established fact. The theory has established relationship. The theory have shown us that this will always be related to this. This concept will be related to this concept. That is what the theory have said. The theory has established a fact, but we need to test the theory. We need to validate the theory. We need to assess that theory. And so statistics becomes handy when we are to do that. Let's consider the theory of demand. The theory of demand have said that other things being all right equal, increases in price will result into lower quantities demanded. That is the theory. So when prices increase, the quantities demanded will decline. That is a theory of demand. This theory should not just be um, in the air, or this theory should not just be hanging in the textbook. There is a need for us to actually test the applicability of this theory. Is this theory true? To what extent is this theory real? Is it relevant? Is it relevant to me? Is it relevant to our society? So there is a need for us to do what? Validate or test that theory. And that's what we call empirical analysis. For us to be able to test the theory, statistics becomes very important. And I'm not going to use advanced statistical tools to test this. So I am going to explain this topic based on what you have been exposed to. So I wouldn't use advanced statistical techniques and I wouldn't use advanced theories. I'm using the theory of demand, okay, to explain. And also, I am also using the basics or the basic statistical tools that you know. We all know that frequency distribution, all right, tables are ways of analyzing our economic issues, and that is statistics. So, with statistics, I will be able to ask a critical question to my life that am I really obeying the law of demand, or is the law of demand applicable to me as an individual? And you can also extend this to the society. So, what do you do? Statistics will help us to gather information that can be used to test this particular theory. And so, from the theory, we know that when prices increase, demand will fall. That is the theory. So, we would go to the marketplace or we would collect data. The process of collecting this data is statistics. When we collect the data, we will analyze that data. The process of analyzing the data using a graph is what? Statistics. Collating the data is statistics. Presenting the data using a table is statistics. And then plotting a graph to understand, does this relationship actually exist, is also what? Statistics. So let's take, for example, that we are considering the demand, okay? Let's take, for example, that we are considering the demand for noodles by Bucci, all right, for the year 2020. So between 2020, from January to June, let me just consider from January to June, we consider the demand for noodles by Bucci. And so, how do I do that? I would ask a simple question, that we have different moons, okay? These are our moons, all right? We have January, February, March, April, May, and June, okay? And June. And for that, I will ask myself a question. What was the price, okay, of a pack of noodles? And that noodles may weigh, say, 80 gram. I might ask myself that question. What will be the price of that? And how many quantities did I actually buy? So I'll start from January. Assuming the price in January, say, is 80 naira. With 80 naira, I was able to buy 25 quantities. I will record that. This table that I have drawn, of course, is what? Is statistics, because tabular presentation of data is a statistical tool, and I'm applying the statistics to this particular analysis. In February, probably the price rises to, say, 90. And because the price has risen to 90, my quantity demanded, say, decline to 20. In March, it became 100. And then the quantity demanded is 15. I will record all of this. In April, it is 110. The quantity demanded is 10. In May is 120, and the quantity demanded is 5. In June, it became 130, and I could only demand for 1. So look at the distribution that we have. This is the demand, all right, by Bucci for noodles in the year 2020, between January down to where? To June. And these are the prices of noodles. As at January 80, quantity was 25, and this continued down till June. Okay? So if this continued down till June, I would decide to do what? Plot the graph. A very simple way I can use to analyze this particular relationship is graph. And graph is statistics. And so I would plot my graph, my price against my quantity. Okay? And for me to do that, what do? I draw my horizontal, my vertical, sorry, axis, and then my horizontal axis. The horizontal axis is my x-axis. The vertical axis is my y-axis. For the x-axis, that is what? That is my quantity, okay? Quantity demanded. And then I have my price in my vertical axis, and this is the origin, okay? And then remember that from our first slide, the prices range from 80 to 130, okay? And then the quantity ranges from 1 to 25. Note that, okay? So if that is the case, I would come for my price from 80 to 120. I can just make a simple assumption that let my price, all right, and my axis, I can say let this be let this be, let me give it a distance of say 20. Okay, and I have I can give a distance of say um, let me start from the 80. So let me assume from here to here is 80. Okay, but I have a unique pattern. This is 80. Okay, this is 90, this is 100. All right, okay, 80, 90, 100, and I have 110. Okay, I have 120, and I have 130, and then my quantity is from 1 to what, to 25. So I can call these 5, okay, 10, 15, all right, 20, 25, and 30. Okay, and 30. All right, so I'll return to my analysis, and I will plot or locate this particular um, coordinates or axis. When the price was 80, the quantity demanded was 25. When the price was 90, 20, 100, 15, and so on. So I would go back to my graph. When the price was 80, the quantity demanded was what? From my slide, the quantity demanded was 25. Okay, and so when the price is 80, you trace it down, quantity demanded is 25. This is the point. Okay, I locate this. This is for January. Okay, when the price was 90, quantity demanded was 20. I trace it down to 20. Okay, this is the point. This is for February. When the price was 100, the quantity demanded was 15. I trace it down, okay, to this point. And this is for what? For March. And when the price is 110, the quantity demanded was 10. Okay, this is April. I identify this point, this axis, that is my what? April. And then when the price was 120, quantity demanded was 5. I trace it up down here, and that is what? May. Okay, that's for my axis, May. And then when the price was 130, the quantity demanded was 1. So 1 should be somewhere here. I trace it up down to this point. Okay, this is the point, and that is what? June. All right, so back to the first slide. So we can see from 80 to 130 and from 25 to 1. So I can join this particular graph and point, okay, and I will draw. Look at it. So this becomes my demand curve. From this graph alone, you will be able to discover that the demand curve is downward sloping from left to right, and that obeys the law of demand. So I know from theory that the law of demand states that what? The higher the price, lower quantities will be demanded. That is the theory. And I want to validate this theory in the life of Buchi for the demand for noodles in the year 2020. And look at what we have here. From that theory, I was able to do what? Tabulate the demand and price
the demand relation as against price relation of Buchi for the year 2020 using a table. This table that I've used here is what? Is statistics. Then I was also able to plot that graph, that particular table, plot a graph for it. And plotting this graph is also what? Statistics. So the statistics has been able to validate the theory of demand in the life of Buchi when considering the demand for noodles. Assuming this particular graph is upward sloping, you would say, oh, the demand for noodles does not conform to theory. The demand for noodles for Onyebuchi did not conform to theory. How am I able to validate that? Through the use of what? Of graph. That was how I was able to validate this particular analysis. So I have been able to show you that using statistical analysis, you will be able to validate theory. I just used the theory of demand. We can also look at the theory of consumer behavior, where you look at the price, the utility of an individual as against the quantity is consuming. Of course, in your theory of consumer behavior, you consider utility and the quantity consumed, the total utility, all right, the average utility. For you to understand or get the total utility as against the quantity, statistics is needed. The presentation of that total utility, all right, with the quantities consumed using a table is statistics. We can also consider the validation of the theory to our production theory, theory of production, and theory of cost, and our market analysis. All of these are in your principles of economics one, okay, that you are doing now. So I am using the simple economic theory that you understand to do what? To actually explain how statistics can be employed in testing economic theory. So in your production, for example, you look at the theory of cost. For you to be able to calculate the total cost incurred in production of goods, you need statistics. For you to be able to measure what quantity of labor should I employ, what quantity of capital should I employ to produce my output is statistics. When you measure that, when you record the quantity, record the output, record the labor and the capital employed, that is statistics. So statistics can be employed in validation or testing of theory. Number two, statistics helps in understanding the basic economic problem. Our basic economic problem is what? Scarcity. The basic economic problem talks about what? Scarcity. And are scarce resources in relation to unlimited ones. Goods are scarce, resources are scarce in relation to the unlimited ones. How do I know that my resources are scarce? I need to measure it. And measuring it, recording it is statistics. How do I know that my wants are unlimited? I need to record them, take note of it. The basic of data presentation, tally, frequency distribution. With this frequency distribution, I can understand how my scarce resources, okay, how my resources is scarce in relation to my unlimited ones. And what do I say? Oh, Buchi, what do you need? I need a car, I need a house, I need clothes, I need this, I need that. I record all of that. How much do I have? Oh, I have 100,000. I have 150,000. And you ask a simple question: can my 150,000 be able to match the car, the clothes, the phone, all right, the bag that I need? No. So for me to be able to understand the basic economic problem, what happens? Statistics becomes handy so that I will know that my resources are scarce in relation to my limited one. If I don't record my resources, If I don't measure my resources, there is no way I can know if they are limited or unlimited. If I don't itemize my wants, okay, according to scale of preference, or I itemize it, there wouldn't be a way I will be able to know. So for me to understand the basic economic problem, even in the society, even in Nigeria as a whole, statistics is what is relevant for me to be able to do what? Understand those basic what? Economic what? Problems. Statistics becomes what? Relevant. Okay? So statistics can also help us in answering the economic question. Our economic question of what? What to produce, how to produce, for whom to produce. With statistics, I will be able to answer this economic question in our society. Of course, you know that what to produce centers on what quantities, in what quantities should I produce? What quantity should I produce? How many quantities should I produce? For me to know how many quantities I should produce, I must know the demand of the society. For me to know the demand of society, I must collect data and itemize. These are the demand of the society. Statistics helps me to understand what I should actually produce. I will conduct a survey of a society. Say, for example, the University of Lagos, the campus. What do we produce? I need to first of all conduct a survey to understand what the people need. So, for me to answer that economic problem question of what to produce, statistics becomes relevant. Again, how to produce? How do I produce? What method should I use? Should it be capital intensive or labor intensive? Understanding this requires statistics, because what method should I use? I need to use an efficient method. How do I know this method is efficient? I need to collate data in order for me to know. Statistics becomes relevant. Which method should I use? If it's labor intensive, I need to ask myself, if I combine 10 labor and 1 capital, what will be my output? I record it. If I increase the labor to 15, what becomes, or what will be my output? I record it. I will then ask another question. What if I use 10 capital and 1 labor? What would be my output? What if I used 15 capital and 1 labor? What would be my output? And we compare. If my output while combining capital more and less of labor is higher than my output while combining more of labor and less of capital, I will go for capital intensive. My ability to make that decision of the method to use is being aided by statistics. So with statistics, I will record my labor quantities and my capital and the output. I would also record the cost involved. That is statistics. Again, for one to produce, what do you produce for? Should it be for the masses or just for a set of people? You can't satisfy all individual wants. So there is a need for us to understand how many of each person's wants is to be satisfied. This is statistics. For me to be able to understand how many of that, what do? I need statistics. So statistics will help us to understand the basic economic problem. One, it also helps us to answer the economic question of what to produce, how to produce, and for whom to produce. That is statistics. I'm using your basic knowledge of statistics, table, graph, frequency distribution, tallies. I'm using it just to explain this basic economic problem. I am not going too deep. All right. Again, um, we consider again that statistics can be used in designing and evaluating development policies. Okay. First, statistics will help us to design development policies. Of course, as you progress in your studies, as you move to year 2, year 3, year 4, even your masters and PhD, you will be able to understand we have different development policies, we have development plans, we have fiscal policy, monetary policy, exchange rate policy, trade policy. In your second semester, year one, you'll be exposed to the fiscal policy, monetary policy, just those tools. You'll be exposed to them. For us to be able to design a development plan, statistics is needed. Of course, a development plan is just a strategy, a document, a chart way, a strategy, a document that explains what needs to be done in order to achieve some certain level of what? Development. That's all. A simple way of explaining that's a development plan. So Nigeria has a development plan that just elapsed, the ERGP, Economic Recovery and Development Plan. That is just a short one, the short-term development plan from 2017 to 2020. The new one they have now is the Fiscal Sustainability Plan. But let's go back to the ERGP. It's just a development plan. It's a strategy that tells Nigeria what to do, how to do it, in order to achieve a desired level of what? Result or improvement in welfare. For them to be able to design that development plan, statistics is needed. Why? For example, if one of the plan is to improve growth, to increase output in the nation, how did they measure the desired level of output? Statistics. Before they design the policy, there's a need for them to assess where we are. How were they able to assess where we are? It is what? Statistics. Statistics enable them to assess where they are, where we are. Okay? So for them to have designed that policy from 2017 to 2020, they need to ask a question. What is our growth pattern between 2010, for example, to 2016, or between 1999 to 2016? What has been our growth pattern? They will calculate the GDP growth rate. Statistics helps us. They look at GDP for 2010, 2011, 2012, 2013, 2014, 2015, and 2016. The recording of that particular GDP is statistics. Aggregation of our output is statistics. When they have aggregated the output, they calculate the growth rate. With that growth rate, they can say, oh, this is where we are. If we do this and do this, we'll be able to get to this particular place. Statistics has helped in designing that particular policy. We look at the fiscal policy. Of course, the fiscal policy talks about what? The expenditure and the revenue constraint or pattern of the federal government. What should be our expenditure? What should be our revenue? Statistics helps in designing our fiscal policy. Same with monetary policy. What should be the volume of money in circulation? That's economics. Statistics will help us to show, oh, this is our current volume of money in circulation. This is the price level. If we increase this money to this point, price level will increase. If we reduce it by this magnitude, price level will reduce. For me to be able to conduct that fiscal policy design or monetary policy design, statistics becomes relevant. Okay? Statistics will also help us to assess the impact of such policies. Okay, ARGP plan was 2017 to 2020. 2020, it has elapsed. The next question is, how have we fared? For us to be able to understand how we are fared, statistics is what is needed. Why? In terms of growth, for example, I would collate the data of GDP growth in 2017, GDP growth in 2018, GDP growth 2019, and 2020, and I ask a simple question. This growth rate, which is the actual, how did it match with the what? With the proposed in the document. So if, for example, ERGP projected that economy will grow by 5.4%, for example, in 2020, you ask yourself the question, what is the actual growth rate of output in 2020? So if the actual growth of output in 2020 is 4.6%, and the document says it should be 5.4%. You just match the two, and you can say, oh, this document, this ERGP plan did not meet the what? The target. You begin to ask a question, why? Statistics is relevant in this. Statistics will help you to match your projected output or your plan as against the actual what? Output or the actual growth rate. So for us to assess our policy, our development plan, statistics is needed. Look at all the development plans Nigeria has had: 7-point agenda, Vision 2020, Vision 2010, the needs assessment, the ERGP we have now. All of these plans, for you to assess them, statistics is relevant. Using mean, ordinary mean, okay, you will be able to assess that plan. For example, the ERGP plan might say, oh, the growth rate or the total expenditure for the government from 2017 to 2020 should be, say, 5 trillion on average. Then statistics will help you to assess what is the actual expenditure of the federal government in 2017, 2018, 2019, 2020. Record it, find the mean. Finding the mean is what? Statistics. Again, statistics complements the use of mathematics in economic analysis. All right? Mathematics is on its own, yes. Mathematics has its own design, yes. But statistics will help to complement the use of maths. Mathematics will show you the way, okay, to follow. Statistics will measure the effectiveness of that way to follow. Mathematics will show you where you are going. Statistics will help you to carry the necessary instruments that will take you to where you are going. So, for example, mathematics, using mathematics, will tell you that for profit to be maximized, you need to set marginal revenue is equals to marginal cost. Mathematics will tell you that if you differentiate your total revenue with respect to your quantity, and you differentiate your total cost with respect to your quantity, you will have your marginal revenue to be equals to marginal cost. That is what? Statistics for you. That is mathematics for you. Mathematics tells you differentiate your total revenue, you get your marginal revenue. Differentiate your total cost, you get your marginal cost. Statistics will provide the data for you to actually test this. So mathematics shows you the way that for you to get your marginal revenue, you need to differentiate your total revenue. Statistics will give you your total revenue. So if statistics does not provide your total revenue, how will you get your marginal revenue? That becomes an issue. So statistics complements the use of what? Of mathematics. So for example, for that firm, you would see, you say total revenue of the firm. Maybe at a particular quantity sold, the total revenue was 40. At another quantity sold, 60. At another one, 65. At another one, 62. Statistics will help you to record this total revenue. Statistics will help you to record your quantity and your sales and your prices, match them to get the total revenue. Mathematics tells you that for you to get your marginal revenue, find the change of total revenue with respect to quantity. So if, for example, quantities were increasing by 1, 2, 3, 4, mathematics tells you that 60 minus 40 over 2 minus 1 gives you the marginal revenue for this point, and that is what? 20. Mathematics tells you that 65 minus 60 over 3 minus 2 gives you 5. That's marginal revenue. And for this next one, it is what? Minus 3. Mathematics tells you how to get marginal revenue. Statistics shows you total revenue. So they both complement themselves. This table that I have used to represent this is what? Statistics. So I can say that statistics, all right, complements the use of mass to solve economic what? Economic issues. Again, statistics is needed for data management for future use. We record our data, data management. Statistics helps us in data management for future use. If we don't have statistics, data cannot be properly recorded. Data will not be properly what? Monitored. Data will not be properly what? Managed. Because statistics is data management. Descriptive aspect of statistics is data management. If we don't have data management, there won't be a future use of our data. Statistics helps us to record, oh, the aggregate of our GDP in 1960 was this, 1961 was this, 62 down to 2018. How do I record this information? I put them on a table and I keep. That is what? That is statistics. All right, so statistics helps in data management for future use. Bloomberg is a financial consulting firm. Bloomberg has so many data of stock markets, the share price of firms in the whole world as far back as 100 years back. Bloomberg has it. How were they able to keep those data? Statistics. That data is relevant for future use, for future comparison and future analysis. Same with CBN, same with Nigerian Bureau of Statistics, same with World Bank, same with IMF. All of their data management is achieved through what? Statistics. And statistics is the foundation for the development of other analytical courses that is used in economics. There are also other analytical courses that are used in economics. As you progress in your studies in your year 3, you were exposed to other analytical techniques, econometrics, optimization models. Econometrics and optimization models, their basis is from statistics. The foundation of econometrics and optimization model is what? Statistics. So in summary, we say that statistics is needed for validation or testing of theory. And I gave you an example of that: theory of demand, the theory of consumer behavior, your production and market. Statistics is relevant there. And I also say it helps in understanding the basic economic problem, our scarce resources. It also helps us in answering economic questions. It also helps us in designing development policies and then evaluating development policies. Statistics also complements the use of mathematics in economic analysis. Statistics helps in data management for future use in economics. And statistics is the foundation for the development of other analytical courses that is used in economics. You might not be able to understand this last point when I say it is the development of, it is the foundation for the development of other analytical courses used in economics, because you have not been exposed to econometrics or optimization models. If you have been exposed to it, you will see that the genesis of econometrics is statistics. The genesis of optimization models is what? Is statistics. So statistics provides the foundation, the background for the advancement of economic analysis. And I would say thank you here. Please, I would like to get your feedback and your comments as regarding this particular course we have discussed. Remember, there are so many ways in which statistics is relevant to economic analysis. There are 1,000,001 ways. There are so many, of course, okay? Not just 1,000,001. There are so many ways that it can be used, okay, to explain economic analysis. I have just only used the simple economic theories that you have been exposed to, and then the simple statistical tools that you have been exposed to explain the ways it can be used. That does not mean it is limited. There are advanced statistical tools that will be used and that can be used. This will be taught in year 2, year 3, year 4. I don't want to expose you to that because that's not your level. And there are also advanced economic theories that statistics becomes relevant, but this is just the basis. Thank you so much and God bless you.